While winter eating often leans toward heavier comfort foods, it is also the season when many people begin looking for ways to support digestion, improve gut function, and restore balance after months of stress, irregular meals, or reduced activity. Fiber supplements become especially popular this time of year, promising quick fixes for sluggish digestion or microbiome imbalance. Yet a growing body of research suggests that whole foods, particularly those rich in natural resistant starch, may offer deeper, more sustainable benefits than isolated synthetic fibers. Among these foods, sweet potatoes stand out as one of the most unexpectedly powerful tools for improving gut health, outperforming fiber powders in several areas that matter most: microbiome diversity, fermentation quality, and long-term prebiotic effects. Sweet potatoes contain a type of carbohydrate that behaves very differently from the rapidly digestible starch found in bread, pasta, or pastries. When cooked and cooled, or even simply cooked in certain ways, they develop higher levels of resistant starch, a form of starch that resists digestion in the small intestine. Instead of being broken down into glucose, resistant starch travels intact to the colon, where it becomes fuel for beneficial gut bacteria. This fermentation process generates short-chain fatty acids like butyrate, propionate, and acetate, all of which are crucial for gut integrity, immune function, blood sugar regulation, and even mood stability. Fiber supplements can increase stool bulk or relieve mild constipation, but they rarely produce robust fermentation patterns like those triggered by whole food-resistant starch sources. This difference becomes especially clear in studies comparing whole sweet potatoes with synthetic fiber powders such as inulin, psyllium, or methylcellulose. In one multi-week trial from an East Asian research group studying traditional tuber-rich diets, participants consuming daily servings of cooked cooled sweet potatoes experienced a greater increase in microbiome diversity than participants who consumed equivalent grams of fiber from powders. Microbiome diversity is considered one of the strongest indicators of long-term gut resilience, protection against inflammation, and metabolic stability. What researchers found striking was that sweet potatoes nourished not just one or two bacterial species, but entire clusters of beneficial microbes, particularly Bifidobacterium, Faecalibacterium prausnitzii, and several butyrate-producing strains that are associated with reduced intestinal inflammation. The fiber supplement group showed limited changes, with diversity improving slightly, but without the broad-spectrum bacterial activation seen in the sweet potato group. Part of this difference comes from the nutritional context of whole foods. Sweet potatoes provide not just fiber but also polyphenol, carotenoids, minerals, complex starch structures, and small amounts of natural sugars that work together to feed a wider array of gut microbes. Many beneficial bacteria require multiple types of fermentable substrates, not just a single extracted fiber. The matrix of resistant starch, soluble fiber, antioxidants, and plant cell walls in sweet potatoes creates a more dynamic environment for fermentation. This diversity of substrates explains why the fermentation from sweet potatoes tends to produce higher levels of butyrate, arguably the most important short-chain fatty acid for gut health. Butyrate strengthens the gut lining, reduces inflammation, helps maintain colonocyte energy supply, and supports healthier immune signaling. Fiber powders do produce some short-chain fatty acids, but usually at lower levels and with less overall metabolic benefit. Another important factor is fermentation speed. Synthetic fibers can ferment too rapidly in some individuals, causing gas, bloating, or discomfort that discourages consistent intake. The resistant starch in sweet potatoes ferments more steadily, leading to gentler digestive effects and a more predictable microbial response. This slow-release fermentation pattern is ideal for winter, when many people experience a slowdown in digestive motility and a reduction in dietary variety. Sweet potatoes provide a warm, comforting food that simultaneously delivers slow-burning prebiotic support. Their natural sweetness and texture fit easily into seasonal meals, making them an appealing choice for those who want gut health benefits without the clinical feel of powders or supplements. Cooking methods also play a key role in unlocking these benefits. When sweet potatoes are baked, steamed, or simmered and then allowed to cool, their resistant starch content increases. Even reheating them later does not eliminate this resistant starch. The structure remains, continuing to support the microbiome. This makes sweet potatoes one of the rare foods whose gut benefits actually improve with meal prepping. Cold sweet potatoes added to salads, grain bowls, or winter lunches are exceptionally rich in this prebiotic form of starch. But even warm preparations, mashed, roasted, or boiled, still contribute a valuable mix of soluble and insoluble fibers that feed gut bacteria and improve stool consistency. A lesser-known advantage of sweet potatoes is their polyphenol content, which includes chlorogenic acid and various flavonoids that act as secondary food sources for gut microbes and also help reduce oxidative stress within the intestinal environment. Fiber powders generally lack these supporting compounds, which limits their functional impact. Polyphenols serve as both antioxidants and modulators of bacterial balance, promoting beneficial strains while helping inhibit overgrowth of opportunistic bacteria. This dual action is one reason whole sweet potato consumption leads to a more stable and resilient microbiome ecosystem. From a metabolic standpoint, these improvements in gut function carry additional benefits. Increased butyrate production supports better glucose control, improved insulin sensitivity, and reduced inflammation, all factors that tend to become more important in winter as activity levels drop and comfort foods increase. Fiber supplements often help with bowel regularity, but they seldom generate these deeper metabolic effects because they lack the complexity of whole food starch structures. What makes sweet potatoes especially appealing is their accessibility and versatility. They are inexpensive, widely available, easy to cook in large batches, and culturally adaptable to nearly any cuisine. Their natural sweetness allows them to replace ultra-processed snacks, while their fiber and resistant starch content help regulate post-meal blood sugar. For people who find fiber powders difficult to tolerate or uninspiring to use daily, sweet potatoes offer a warm, flavorful, and nutritionally complete alternative that feels more satisfying and emotionally comforting, an important factor for sustainability during colder months. Taken together, the evidence suggests that gut health thrives best when fed by whole foods, not isolated fiber fractions. Sweet potatoes demonstrate how foods naturally designed by biology bring together multiple components that work synergistically to support a diverse, stable, and metabolically active microbiome. They offer prebiotic effects that extend far beyond simple fiber supplementation, improving fermentation quality, encouraging beneficial bacteria, and enhancing short-chain fatty acid production. In a season when digestive health often feels more fragile, sweet potatoes provide not just nourishment, but a deeper form of support, one that aligns pleasure with function, warmth with resilience, and tradition with modern nutritional science.